We're now going to look at some problems where we are given an equation written with polar coordinates, and we want to convert that to an equation with the variables x and y, so that the rectangular coordinates. So earlier we converted a point given in polar coordinates to rectangular coordinates, but now we're actually looking at equations. And what we're going to do in a minute, you'll see, if I go back to the formula sheet, the same formulas we used to convert back and forth between points in polar coordinates and rectangular coordinates, the same formulas that we used for points, we're now going to use for equations. So you'll see how this works as we do some examples. So this first one, this is actually an equation of a function written in polar coordinates, r equals 10. If you think about it, r is like the radius, so you can imagine maybe that r equals 10. If you have like a radius of 10, then if you can imagine like a circle where the radius is 10 every place, it would sort of make sense that once we do this, when we write this in rectangular coordinates, it's got to be a circle. R equals 10 sort of makes sense. It's almost like when you have a XY graph, and we want to graph x equals 2, well, what does that mean? That's a straight line where every point on this line, x is equal to 2. Well, if we have a circle, I can choose any point on this circle. For any point, what is r? R is always 10 for any point on the circle. Now, each point will have a different angle, a different theta. Just like here, each point on this line, the y will be different, but the x is the same. Same idea here. The r is the same, but the x is different. Now we want to go ahead and mathematically show how we can take this equation in polar coordinates and convert it to an equation with rectangular coordinates, which means an equation with x and y. And what we're going to do is, if you recall, one of the formulas that we're given to go back and forth between rectangular and polar coordinates is r equals the square root of x squared plus y squared. Well, for this, I'm going to go ahead, and if I square both sides of this equation, then we get r squared equals x squared plus y squared. The equation I've been given is r equals 10. I'm going to square both sides of that equation, and now it's r squared equals 100. Now if I compare this with this, r squared equals x squared plus y squared, for my specific equation, r squared equals 100, how about I replace r squared with x squared plus y squared? Now if you recall from geometry or other classes, what's the standard equation of a circle? It's x squared plus y squared. That's interesting. For the equation of a circle, we also call this r squared, where r squared is the radius. So this is a circle with the center at the origin, and the radius would equal 10. because if this is r squared, then r would be 10. So I'm going to look at my possible answers here. The first part says, what's the graph of this equation? So I would enter x squared plus y squared equals 100. And then what is this? Well, it's a circle. Here it says radius 100. It's not correct. Here, circle with center at 0, 0, radius 10. And then they give you 4 graphs where you sort of choose. I know these are pretty small. Here are 2 circles. I guess if you try and analyze which one has a radius of 10, it's pretty hard to see. I don't know if I can expand it enough. So this one actually, if you can tell, looks like it has a radius of 10. This one, the radius looks a lot smaller. So this looks like the correct choice. All right, so actually not too bad, that first one. Now here's another problem. Now I have an equation where theta equals pi over 6. Let's just think about what that might look like. Let's think about, once again, looking at polar coordinates. So here we're saying the angle is pi over 6. Well, pi over 6 is right here. So what this means is the angle always has to be pi over 6. And just like the examples we did here, in this case, x is always 2, and the y always changes. In this case, the r is always 10, and the angle's changing. We know what's going on here. The angle's staying the same. So I have all these points on here. Each point on this line, theta is pi over 6, and you know what is changing? The r. Each point on this equation, r is changing, but the angle's the same. And that's what this equation says. Hey, we have a function here where the angle is always pi over 6. So my guess is when we work out the math of this, this is probably going to be a straight line with some kind of an angle. So how do we actually come up with the equation? Well, in this case, if I go back to my formula sheet and I look, how does theta relate to x and y? Let's look at this right here. Tangent of theta equals y over x. So I'm relating theta and x and y. So let's think how we might use that. So here's my initial equation written with polar coordinates, and I know that the tangent of theta equals y over x. How about I go ahead and, since theta is pi over 6, I just plug it in here. And actually, we know what tangent of pi over 6 is. That's a special angle. If you go to the unit circle, here's pi over 6. So tangent is going to be sine over cosine. So let me go over here and just, let's figure out what the tangent of pi over 6 is. The sine is 1/2. The cosine is square root of 3 over 2. Complex fraction, once you reduce it, it's 1 over square root of 3. Now in the trig world, I'm just going to leave this. I mean, some people might want to rationalize this and call this square root of 3 over 3. But usually, we can leave square roots in the denominator. So if tangent of pi over 6 is 1 over the square root of 3, I'm going to replace that here. And once I do that, then I have this equation with x and y and just a number. Now for equations, we always usually get y by itself. So if I multiply both sides by x, I would get 1 over square root of 3 times x. And this is in fact the equation of a straight line with a slope of 1 over square root of 3. So that would be the equation in rectangular coordinates, and it makes sense because that's the equation of a straight line. And what is the graph? Well, actually it's a graph, it's going to be in quadrants 1 and 3, so a line in quadrants looks like this one. And then, of course, we already know what this looks like. Looks like this is the correct graph. All right. Hopefully not too difficult so far. Let's look at a few more. How about the next one? Same instructions, transfer the polar equation to an equation in rectangular coordinates. R sine theta equals -2. Let's go back and look at our formulas to see if we can figure out something. Here's the polar and rectangular coordinates. I notice I have x equals r cosine theta, y equals r sine theta. I'll write them down here. Well, here I have r sine theta. R sine theta is y. I think it's as simple as that. Now when I look at this, I don't have a good feel for what that graph should look like. But when I convert it to rectangular coordinates, y equals -2 is simply a horizontal line that goes through y equals -2. So that one was, I think, about as easy as you can get. So if I look at the graphs, looks like this one down here is the correct one. Wow, not difficult at all. And then let's do one more. Another type of problem that you'll have in the homework. Oh, now let's do two more. Here's one, just like the one we did. R cosine theta equals -8. Of course, R cosine theta is actually x. So this one just becomes x equals -8. So there's the graph of x equals -8. It's going to be a vertical line, and since it's -8, it's got to be this one down here. All right, now we'll do one more. Let's do Here the print is very small for some reason. I will try and make it a little bit larger. Same thing, transform the polar equation into rectangular coordinates. R equals 4 cosine theta. So this one, there's a few hoops you have to jump through to do this one, but let's go and do it. So this is something where probably on your own you might not have been able to figure it out, but here are in a minute, the equations we're going to use. I'm going to use x equals r times cosine theta, and also r squared equals x squared plus y squared. What I'm going to do, I'm going to take this equation and multiply both sides by r. And yet with r squared equals 4r times cosine of theta. And then you realize, why don't I replace r squared with x squared plus y squared? And why don't I replace r cosine theta with x? So when I do that, so the r squared becomes x squared plus y squared. The 4 is here, but r cosine theta is x. So these are just from the formula page. Now you may not at this point know what that is, but if you've done some math or algebra long enough, you realize that, well, let me just do it. I'm going to get everything on one side. So I'm going to have x squared minus 4x now you may or may not realize, but if we do a procedure called completing the square on this equation is actually going to be the equation of a circle. So let me show you how that's done. So completing the square is a technique that we oftentimes use in math to figure out what's an equation. So completing the square says, I look at these x terms, I take this coefficient in front of x, and I go ahead, let me show you over here, and I take that number and I divide it by 2 and I square it. So this ends up being 4. And then I take that number and I add it right here, but of course if I add 4 to this side of the equation, I have to add 4 to the other side. Now the reason we do this is because this right here is what we call a perfect square trinomial. This actually factors, and when you factor it, it becomes x minus 2 squared. And then you have y squared here equals 4. Now you have an equation of a circle. The standard equation of a circle is written like this. I'll explain what this means. This is the equation of a circle, and the center of the circle would be at HK, and then the radius of the circle obviously is R. So that's what we have. We have the equation of a circle. So where's the center? Well, the center is going to be 2, and over here K is 0. I mean, we could think of that equation as x minus 2 squared plus y minus 0 squared equals 4. So the center is going to be 2, 0. 4 is the radius squared, so square root of 4 is 2. So the radius equals 2. So if we would try and graph that, the center is at 2, 0, 1, 2. So there's the center. Since the radius is 2, then we move 2. I think it's going to end up looking something like this. So to answer the questions in the problem, the equation ends up being x minus 2 squared plus y squared equals 4. And the graph is a circle with the center at 2, 0. And then if we look and we try and find which one of these, looks like it's going to be this one. All right, so those are the kinds of problems you'll be given where you are going to convert an equation in polar coordinates to an equation in rectangular coordinates.